Hello, hi everyone. Welcome to the Student the Brand. So this is our Shiva sir. Today topic is human eye and colorful world. Today topic is human eye, human eye and colorful world and colorful world. So in this video we will discuss about human eye parts and function. Human eye parts and function. So what we'll discuss human eye parts and function, parts and functions, and the second one is myopia, and third one is hypermetropia, and fourth one is so presbyopia, cataract, astigmatism. So remaining all are there. So still we'll discuss about these three parts. And next one, prism. So recombination of splitting of white light and recombination of spectrum of white light. And fifth one is raindrop. So sixth one is refraction of light. Refraction of light. So that is nothing but by atmosphere. And the seventh one is scattering of light. Scattering of light. So we'll discuss all these seven points. So human eye parts and functions: myopia, hypermetropia, prism, raindrop, refraction of light, so scattering of light. So these points we'll discuss so intensely all the points. So now we can see. So we'll go with the human eye parts. Human eye parts and functions we'll discuss now. So human eye, how to draw the diagram. So while drawing the diagram, so it is easy way. So I'll draw an easy way how to draw the diagram. So I'll show you. So I am considering this diagram like this. So you can draw the circle. So if it is possible, you can draw the circle. And correct the front part and lower part. So here, so I'm considering this part. We can cover up, and here also. Then you can join this part. You can join this part like this. So you can join this part. So here, okay, like this you can join, and here also like this, okay. And here is the lens, eye lens. So I'm drawing the eye lens here. So here I'm drawing the eye lens. So here I'm drawing the eye lens here like this. Okay. So here ciliary muscles. I'm taking the ciliary muscles here. Ciliary muscles. Okay, ciliary muscles. So here also ciliary muscles I'm taking like this. So here I'm considering. Okay, so here I'm considering ciliary muscles. Okay, so here you can observe I'm taking like this, and here also until here. So here I'm considering. So this is optic now here. This is our optic now. So I'm considering the optic now. Okay. So here I'm considering like this. So cornea. This is the cornea. Okay. So now we will mention the parts. What are the parts are there here? So you can see this is a cornea, the front portion, cornea. Okay. This is a cornea I'm considering. And this one is the ciliary muscles, ciliary muscles, ciliary muscles, ciliary muscles. Next one, this one is the islands, islands. Islands or crystalline lens also we can say. Islands or crystalline lens also we can consider. So this one is the iris, iris, and here it is the pupil. This gap is called pupil, pupil, and this is the aqueous humor, aqueous humor, aqueous humor. I'm considering is the aqueous humor, aqueous humor, and here it is the vitreous humor, vitreous humor, vitreous humor, and here it is the, so these are the optic nerve, optic nerve. So this optic nerve I'm considering. So these are the parts about human eye parts. So you can see human eye, human eye parts. Simply we can say human eye. This is a human eye. This is about human eye. Okay. Now, so one by one, so we'll talk about. First one is cornea. So this is a cornea. This is a front layer. So most of the refraction takes place whenever the light enters through this part only it will enter. So it is a thick layer. It is a protective layer of the human eye. Most of the refraction takes place at this part. And next one here we are considering the iris. So iris is a dark muscular diaphragm. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is the dark muscular. So this iris is the dark muscular diaphragm which controls the size of the pupil. So this gap is called pupil. So pupil will control the amount of light entering into the eye. Pupil will control the amount of light entering into the eye. And so aqueous humor, aqueous humor. So it is jelly type liquid present between cornea and islands. So the jelly type liquid present between cornea and islands. So it provides blood and nutrition to the central cornea. Okay, and also maintain that shape. Next one, islands. So this is the islands. This portion is the islands. So crystalline lens. When light ray falls on it, it will converge and make it falset. So here it's a retina. So here I'm considering one portion that is called retina. So retina will be there. So here I'm taking this retina. Okay. So whenever the light rays falls on it, it converts the light rays and make it falls at retina. So at the retina. So this is the retina. Okay. Next one, ciliary muscles, which holds the lens. So ciliary muscles which holds the lens. Okay. Whenever we are seeing the far distance as well as near distance. So whenever we are want to see far distance as well as near distance. So it adjusts its focal length. So it adjusts the focal length. So if you are seeing the far distance, our eye lens become thin, focal length increases. So ciliary muscles will be relaxed. We can able to see far distance. When we are seeing the nearby object, eye lens will become thick. So ciliary muscles will be contracted. So focal length will be decreases. We can able to see nearby objects. So ciliary muscles. So it will help the seeing the nearby object as well as far object by adjusting the focal length of the eye lens. And vitreous humor. So vitreous humor is a jelly type liquid present between the eye lens and retina. So this entire portion is filled with vitreous humor. It maintains the shape of the eyeball. So it provides blood nutrition to the eye. And next one, retina. So whenever it is a light sensitive screen, So after refraction, wherever light ray passes through, after refraction, light rays will meet at retina. So there rods and cones are present. So there are two light sensitive cells are present. Rods and cones. Second one, cones. Rods sense the intensity of the light. Cones sense the color of the light. And next one, so at retina, real and inverted image will form. Real and inverted image will be forming at retina. Okay, that will be converted in the form of electrical signal that will pass through the optic nerve. So these are the nerves, electrical signals. Electrical signals will pass electrical impulse. So that electrical signal that will be converted in the form of electrical signal that will be passed to the brain through optic nerve. So here is the blind spot. So here there won't be any images will form. There is a dark space. Okay, wherever the light rays are wherever the nerves are passing to the brain. So there blind spot will be there. So this is about eye parts and function completely. So brief idea about eye parts and function. Next one. So we'll discuss about myopia. We'll discuss about myopia here. Okay. So now myopia is nothing but, so I'm considering myopia. Myopia is nothing but the person can able to see. So here you can see I'm taking this one. So one case. So I'm taking this is a near point. So I'm taking 25 centimeter and this is infinity centimeter. You can consider, or infinity you can take. Okay. So this is a person. Normally, what is the near point and far point? Before that, so I'll discuss 2 points: near point. So first one, second one is far point. So near point is nothing but the near distance up to which the person can able to see clearly without any strain. That is called near point, or the minimum distance up to which the person can able to see. So without any strain, a healthy person can able to see the object, that is a 25 centimeter. So below that one we can't able to see. So if you are trying to see below 25 centimeter, our eyes will get strain and pain. So far point, the maximum distance up to which, or the farthest point up to which the person can able to see clearly without any strain, that is infinity. So infinity. So near point is 25 centimeter, far point is infinity. So the range of vision. So the healthy person, a normal healthy person can able to see 25 centimeter to up to infinity. So this is called range of vision. So the minimum distance up to which the person, least distance of distance vision. Least distance of distance vision is nothing but the minimum distance up to which the person can able to see clearly without any strain, that is called least distance of distinct vision. So here the range of vision. So this is the range of vision, 25 centimeter to up to infinity. A healthy person can able to see. So here I hope you got it. Near point and far point. So range of vision 25 centimeter to up to infinity. So here myopia. So myopia person. So myopia is nothing but the person can able to see. The person can able to see near distance, but he can't able to see far distance object. He can able to see 25 centimeter, so but he can't able to see the infinity point. He can see this one, but so his far point is less than infinity. Somewhere here less than infinity. So below infinity he can able to see. So this is a far point of myopic person. So this is a near point and we are considering. This is a far point of myopic person, and up to there only he can able to see. He can't able to see this point. So how to draw the image? So in the form of diagrams. So now I will show you. So remember this point. So remember this incident. So okay. And so once again I will draw. Here I am taking. So the person is here. Okay. So here he can able to see 25 centimeter. So he can't see infinity, but he can see somewhere. So this one he can see, this one he can see, he can't see the infinity. So how to draw in the diagram fashion? So I am taking the diagram, eyeball. So convex lens will be there, convex lens. So here is the eye lens. I am considering this one, and so minimum point. So there is a minimum line. So here I am considering this is a 25 centimeter N. So this is a far point. So he can see this point. He can able to see this is a far point. The person can able to see far point. If the light rays are coming from here, the light rays are coming from this point. Okay. So he can able to see. So he can able to see this point. So he can able to see this point. Okay. So like this. So you can able to see that point. So now you can observe minimum point. So least point is 25 centimeter. So maximum point is less than infinity. So less than infinity. How to draw? So we'll see here. Now you can see this is a 25 centimeter N, and this is a far point. So from the light rays are coming from here, you can able to see. So this is the far point of myopic eye, far point of myopic eye. And so if the light rays are coming from infinity, how the light rays will meet? So we will see the light rays are coming from. So I am taking this one. So I am considering here. Okay. So if the light rays are coming from infinity, so this is a near point. So I am considering this a far point. So if the light rays are coming from beyond the point, light rays means that's why I am drawing the dotted lines. So infinity. So if the light rays are coming from infinity, how it will be? So it will meet in front of the retina. So here like this. Like this. So light rays will converge and meet in front of the retina. So here it is retina. If the light rays meet at retina, then only we can able to see. So if it is meet in front, we can't able to see. So this is a myopic eye. Myopic eye. So now we can see. I am taking like this. So I am considering the eye lens. Okay. So I am taking the line. So now which lens we are using? We are using concave lens for correction of this defect. So which lens we are using? Concave lens. So I am taking the concave lens here. So here one light I am taking like this. So here I am taking, and here also I am taking. So those are diverged those light rays. Light rays are diverged. Light rays are diverged. After that, so those will meet at retina. So like here, and here also. Okay. So I am taking like this. So here I am considering. So this is a near point, and this is a far point F. So we are extending these light rays. Those will meet at far point. Okay. So this is a correction of myopic eye. Correction of myopic eye. Correction of myopic eye. Okay. So I hope it is clear. Myopia, far point of myopic eye, correction of myopic eye. So here, this is the condition. If you remember this one, it's very easy to draw the diagram. So 25 centimeter infinity. So anyway, least distance we know 25 centimeter. So far point we know infinity. But for whichever person have myopia, the person can't able to see the infinity point. But he can see less than infinity. So less than infinity, he can see. Less than infinity, he can see, that is called far point. So far point. So this is a far point of myopic eye. So if the light rays are coming from infinity, in case If the light rays are coming from infinity, what happens? So those will meet in front of the retina. So this is a myopic eye, and for correction of myopic eye, we are using concave lens. For correction of myopia, we are using concave lens. So there is a correction of myopic eye. So this is about myopic. So eye. Next one, hypermetropia. Coming to hypermetropia. Hypermetropia. So here you can see. Hypermetropia is nothing but so same condition. So here I am considering. So the person you can observe. So this is a 25 centimeter. This is the infinity. So you can see the 25 infinity point, but he can't see the 25 centimeter. But somewhere between. So here he can able to see. So that is n dash I am considering. So this is n already I am considering this n. So near point. So that is n dash. Myopic eye near point. Myopic eye near point. So this hypermetropia. So hypermetropia. So you can see this point. He can't able to see this point. So how to draw the diagram? How to draw the diagram? So now you can see I am taking like this. If the light rays are coming, so you can able to see, as I said, you can able to see from this point. If the light ray is coming from beyond 25 centimeter, so this is the 25, so the beyond 25, you can able to see. You can able to see this point, this is the n dash. So light rays are coming from this point. So I am considering this one. From here you can able to see. Yes, so this is a near point of hypermetropic eye. Near point of hypermetropic eye. So next one, hypermetropia. So how it will be? So if the light rays are coming from near point, where image will form? So we'll see now. So if the light rays are coming from 25 centimeter, where image will form? We'll see now here. So I am considering like this. So this is the 25 centimeter n. So this is the n dash. So here I am taking. See, this is the near point of hypermetropic eye. From here you can able to see. Normal near point is 25 centimeter. So more than that only you can able to see. So at 25 centimeter you can't see. If the light rays are coming from this 25 centimeter, so where light rays will meet, now we will see. So light rays will meet, so beyond retina here. So you can't able to see this one. Okay, so this hypermetropic eye. Hypermetropic eye. Hypermetropic eye. Metropic eye. So next one, correction of hypermetropia. So I am taking this one like this. So here I am considering. So light rays. So I am considering the eye lens. So this is the near point. This is the n dash. Okay. So I am taking the convex lens. Convex lens I am taking. So light rays I am considering here. So here if you take, this is a 25 centimeter. So n I am taking, this is n dash. Okay. So after converging, again it will converge. So again it will converge and meet at retina. So like this. So here 2 times conversion will be there because convex lens, right? So if you are extending from here, from this lens, those light rays will meet at n dash. Okay. So this is a correction of hypermetropic eye. Correction of hypermetropic eye. correction of hypermetropic eye. Okay, so if you remember this case, if you remember this one, it is very easy to understand the concept. You can draw easily diagrams also. The person, whoever has my hypermetropia person can't able to see near point, but he can able to see far point. So he can see this point, but he can't see this point. But somewhere between beyond 25 centimeter, he can see that more than 25 centimeter we can consider. So like this. Okay, so that's why near point of hypermetropic eye, correction of hypermetropic eye. So that is about hypermetropia. So presbyopia, the person can't able to see near point as well as far point. So bifocal lens we are using. Upper portion is concave lens, lower portion is convex lens. Upper portion is concave lens, lower portion is convex lens. Upper portion is concave lens, lower portion is convex lens. So bifocal lens we are using. So here I am taking this so convex lens. So here I am considering the convex lens. So like this. So like this I am taking. So upper portion will be there. So here upper portion concave. So lower portion is convex lens will be using. So presbyopia, the person can't able to see near distance as well as far distance. He can't able to see near distance as well as far distance. For correction of presbyopia, we are using bifocal lens. Upper portion is concave lens, lower portion is convex lens. Astigmatism is a medical condition. Astigmatism is a medical condition. So a milky and cloudy will form on the eye lens. So by laser surgery only we can able to remove that defect. So that is about astigmatism. Cataract. So one is presbyopia. We discuss presbyopia, and the second one is cataract. So the cataract only, the milky and cloudy will form eye. So cataract. So in the cataract defect, the milky and cloudy will form while getting aged. So it will become like this. By laser surgery only we can cure the defect. And next one, third one is astigmatism. So here in this case, the person can't able to see the vertical lines and horizontal lines properly. So by using suitable cylindrical lens, we can correct this defect. Once again, presbyopia. So the person can't able to see near as well as far distance. So for correction of this defect, we are using bifocal lens. So cataract, a milky and cloudy will form on the eye lens. So by laser surgery only we can able to remove this defect. And astigmatism, the person can't able to see vertical lines as well as horizontal lines. So by using suitable cylindrical lens, we can cure the defect. So that is about presbyopia, cataract, and astigmatism. And next one, so we can see when light is passing through the prism, so it's split into 7 colors. So I'm considering this a prism. So this is a prism I am taking. When the light ray passes like this, it's split into 7 colors. So I am considering, so this is the initial direction of the incident ray. So split. So how many light rays? Like 7 colors. Order violet, indigo, blue. 1, 2, 3, 4, 5, 6, 7. So order will be violet, indigo, blue, green. So I am considering this order. So you can observe. So you can see the order. Okay. So like this. Here 7 colors. 1, 2, 3, 4, 5, 6, 7. Violet, indigo, blue, green, yellow, orange, red. So like this 7 colors. Violet, indigo, blue, green, yellow, orange, red. These are the 7 colors. Okay, according to the refractive index, according to the wavelength. according to the refractive index, wavelength. So the light ray will bend. Okay, so here you can see these colors. Okay, so that is about splitting. Here 2 points I will discuss. So splitting of white light into 7 colors. So dispersion, splitting of white light into 7 colors is known as dispersion. So spectrum is the band of colors. The band of colors is known as spectrum. So dispersion means splitting of white light into 7 colors. So from white light into 7 constituent colors is known as dispersion. So those 7 colors will form like a band on the screen is called spectrum. Is called spectrum. Okay, so dispersion, splitting of white light into 7 colors. So that is known as dispersion. Spectrum means so all 7 colors will form like a band on the screen. Those are, so that is known as spectrum. Okay. So now, so we can see recombination of spectrum of white light. Recombination of spectrum of white light. We can see, so recombination. So Newton normally placed one prism, so it's split into 7 colors. So he placed inverted prism. He placed the inverted prism like this. So this is a inverted prism. He placed it like this. So those 7 colors again split like this. So like this will come. So those 7 colors. So it will come. So violet, red, violet, red. So here white light, white light. So here on the screen, white light, white light, white light. Okay. So it's split into 7 colors. So if you place an inverted prism besides of this normal prism, then you will get, so outcome as a white light. So this is a recombination of spectrum of white light. Recombination of spectrum of white light. Spectrum of white light. White light. So that is about recombination of spectrum of white light. Next one. So we'll go with the rainbow formation. That is nothing but so previously by prism we got the rainbow. Now in the naturally, so where it will happen, where we can able to see, so in the sky, so during the rainy time. Okay, after rain shower, so each raindrop act as a tiny prism. So when light falls on it, it's split into 7 colors. So like this, split into 7 colors. Those 7 colors. So internally reflection takes place. So violet, red. So this is the violet and red. Okay. So here what is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. So total internal reflection. Why? Some portion of the light will be observed, some portion of the light will be coming out. That's why we are not talking about completely total internal reflection. So we are considering internal reflection. So refraction, when a light moves rarer to, so here I am taking the rarer medium, denser medium. This is the air and water. So when light passes from rarer to denser, so refraction takes place. Anyway, if it is moving from one medium to another medium, refraction takes place. That's why refraction. So immediately after refraction, it's split into. So whenever refraction, so at that point only dispersion starts. So refraction, dispersion, and internal reflection. So the formation of rainbow, okay, by water droplet. So raindrop. So formation of rainbow by raindrop. So this is a raindrop. Okay, so what is the phenomena? So refraction, dispersion, internal reflection. Refraction, dispersion, internal reflection. So this is the phenomena involved in the formation of rainbow by raindrop. Okay, so then next one, atmospheric refraction. So the refraction takes place by the atmosphere, that is called atmospheric refraction. Atmospheric refraction. atmospheric refraction, atmospheric refraction. Okay, refraction takes place by the atmosphere. So normally a local condition, so one person is here, so here is a fire, so another person is here, so person A, here person B, so a fire will be here. So when the person A sees the person B through the fire, so this person B image will flickering, blinking. Why? So hot air act as a rarer medium, cold air act as a denser medium. When you view into that, so light bends so many times. That's why this image of the person flickers, appears blinking. So that's why, so it appears flickering. Okay, due to atmospheric refraction. This is the lower case. So whereas the higher case is stars appearing twinkling, because there are so many refraction takes place. So from star to earth, so many refraction takes place. So that's the reason it appears to be twinkling. It appears to be twinkling. Okay, next one, scattering of light. So scattering of light. Scattering of light is nothing but scattering of light. Scattering of light. Scattering of light. Scattering of light is nothing but, so here, so the particle is there, light is coming like this. So here I am considering like this. So wavelength, like this wavelength. So this is a crust, trough, crust, trough, crust, trough. So the wavelength of this, so the distance between two consecutive crust or two consecutive trough is called wavelength. So if the size of the particle, so the size of the particle comparable to the wavelength of the light, or comparable or almost equal to the wavelength of the light, then so this particle will absorb the light. This particle will absorb the light and re-emit in different directions. Re-emit in different directions. The re-emission of light in different direction with a different intensity is called scattering of light. The re-emission of light in different directions with a different intensity is called scattering of light. Okay, so a Tyndall effect. Tyndall effect, if you consider Tyndall effect. Tyndall effect means, so the path of the light becomes visible. Well, scattering of light takes place by the colloidal solution. Suppose you are taking the lemon water. So if you are sending any laser light, if you send, so the path of the light appears very clear. Or in the morning time, you can see when you open the window, sunrise will come. The dust particles will fly. Able to see the movement of the dust particles very clearly. So the path of the light becomes visible when the scattering of light takes place by the colloidal solution. So by colloidal solution, scattering of light takes place, then path of the light becomes visible. That phenomenon is known as Tyndall effect. So here we can able to see clearly the path of the light. So that is called Tyndall effect. Okay. So this is about, and 2 minutes sunrise and 2 minutes early sunrise and delay sunset also due to atmospheric refraction only. So whenever light ray passes, because of the atmosphere, it bends. So that is the reason 2 minutes early, advanced sunrise and delay sunset because of atmospheric refraction. So color of the sky, so colors, so reddening color during evening time and morning time, it appears reddish color because scattering of light. Even sky appears white colors sometime. So during noon time, it appears white due to scattering of light. So it appears blue color remaining time. So due to scattering of light. So related to colors means scattering of light. Related to positions. Related to position means, so it appears atmospheric refraction. So this is about human eye and colorful world. So still so many points are there. So we can't cover in one video. So remaining points we'll discuss in some other video. So if you like this video, if you like this content, so please do like, please do like, share and subscribe my channel, Student the Brand. stored in the brand. And so if you want CBSE grade 10 physics course, okay, so like these 4 chapters will be explained. So light reflection and diffraction, human in colorful world, electricity, magnetic effects of electric current, these 4 chapters. So soft copy will be provided, doubt clarification will be there through live sessions. So doubt clarification will be there. At the same time, soft copy notes also will be provided, and 100 definitions from these 4 chapters. Okay, so here you can see this is my notes I have written, so you can see clearly. So this is the notes you can observe all the, so my handwritten notes. Okay, so you can able to see all the diagrams, everything clearly, everything clearly. So this is the handwritten note. So you'll get it PDF soft copy, you will get it. So this is handwritten note. So this is human eye notes. So just whatever chapter I explained. So this is about complete notes. So you will get pin to pin all the diagrams, everything. Okay, and electricity 100 definition, as I said, 100 definitions I said, right? 100 definitions also available. So here, so from that time onwards I am saying 100 definitions, right? This is the 100 definitions. So more than 100 will be there. So 100 definitions like this from chapters, you will get it. So here you can see 100 definition, all definitions, see 46, 48 and 54, 63, like this, all definitions will be there. So you'll get it, all the definitions. So actually more than 100, so 111, 222, so 111, okay, 112 are there, like you can see all the definitions. Okay, so here you can observe, so all the definitions, so each and every point, so each and every word definition will be there, like atmospheric refraction, scattering of light, Tyndall effect, astigmatism and correction. So like color blindness, night blindness, blind spot, so monochromatic light. So here everything, all the points, so with clear definitions, and that is about so 100 definitions and human eye notes. So still all remaining chapters notes are available. So those who need, so you can get the course. So you can contact to this number 9849812804. So we'll discuss further details. So this course I am providing with a price of 500 rupees. I am telling the price itself. So price also with the price 500 rupees I am providing this course. So live session will be there. So like this explanation will be there. At the same time your doubt clarification will be there. And notes also will be provided. So time to time doubt clarifications will be there. So exam will be conducted. So slip test will be conducted. Assessment will be conducted. So everything will be conducted, and evaluation also will be available, and you will get the results also, and where you did mistakes everything will be clarified. So how to rectify and how to write the correct answer also, everything guidance will be given. So with the cost of 500 rupees. So if you like this explanation and course details, so you can contact to this number. Still regarding the classes, everything I'll give the details. So this is our Siva sir. Thank you so much.